Hello and welcome. It is time once again to try to fix something, and today on the workbench we have another dead PS5. And as I was taking it out of the box, I realized why it was, most likely why it is dead and wrapped in plastic. If you can look. Yeah, there's going to be some nastiness in this thing. And I have not bothered to unwrap it yet. I may take it out in the yard and unwrap this beast. But yeah, that's what I'm dealing with at the moment. And we got some corner damage here, I see. I probably have a cover somewhere. Wonder if I bet that happened shipping. It was packaged reasonably well. Anyway, let me take this elsewhere off the workbench and get it unwrapped, and then we'll see what how nasty it is underneath the covers. All right, well, I did unwrap it out in my driveway. Had it laying on a towel. And we had a few dead critters fall out. She is still sealed though, so that's surprising. At least I think it's sealed. That corner looks like it's up just a little, doesn't it? Yeah, that seal's in pretty good shape though, so I don't think she's been opened before. But that didn't stop the roaches from getting in there. Let me get these covers off. Well, I forgot to show you that it wouldn't power on. And I plugged it up and there was an explosion inside. I did not get it on video though. There was a loud bang inside there when I plugged it in. So, yay. Yeah. So there's going to be some carnage in that power supply right now. A big mess, I have a feeling. I don't know what popped, but it was not good. She's dead now. If it wasn't before, she's dead now. All right, I've managed to work the power supply out of there, as you can see. And look down in that power supply. Yeah, there's something in there. So, all right, we need a 400 FR. Let's go over and look in the old pile of power supplies. That's a DR. Here's an FR. There we go. That should do nicely. Okay. Let's see if that gets this thing up and running. Then we'll take a look at the supply. All right. Well, our repaired supply is in there from my stockpile of parts. Is she going to work? I bet she does. There we go. Maybe give some video. Yeah, she's going to give some video. Excellent. All right, so we have a power supply to fix if we can. There was quite the explosion when I plugged it in, so it sounded almost like a capacitor blowing up. So let's see how bad it is when we get in there. But and she's going to need a little cleanup. Not as bad as I thought it was going to be inside, but she will need some cleanup. Hey, initial setup screen. Okay, that's odd. Like it's never been used, and it's definitely been used. Looking at the amount of dirt and roaches in it. Okay, well, let's get this inside and see how messy it is. All right, well, here we are inside of the workbench, and I have prepared a place to put this power supply. And the first thing I should probably do is go ahead and take this antenna off before I damage it accidentally. Okay. And now the prying begins. And this is the part I don't recommend to anyone if you're not familiar with working on electronics. But please take the screws out if you're going to, and if you are familiar. I always forget that. But as I was saying, there are dangerous voltages inside that can hurt you or kill you. that's something. Ugh. And I did have this thing plugged in, so I'm being very careful not to touch any of the circuitry right now, because there is likely to be some charged capacitors in here. And this is one of the models with the DNP014 on it, which I cannot get. Not yet, anyway. Wow. At least they're all dead. I can get that in the garbage can over there. Ugh. Alright, I'm not going to handle this a whole lot until I discharge some capacitors. And where are said capacitors? Hard to find them from this side. Oh, capacitor exploded there. Yep. That's odd. Unless there was, well, major problems with the power factor correction circuit. And then that could have, the voltage across those capacitors could have gone really, really high. That's probably what happened. Let me discharge. I have a feeling the caps are discharged already, but let's make sure. Yeah, I think they got discharged when it went boom. Yep. Nothing there. So, we blew up one capacitor. I'm not sure if I have any of those. I might. Or I could take one from a donor. So that's what went pop. I kind of thought it sounded like a capacitor. I've got to clean some of this off of here. These critters are staring at me. Nasty. They crawled in there. All right, they're crawled around, yeah, in the feedback circuitry for the power factor corrector. That's what they did. And when they did that, the PFC went a little wild and was no longer charging those caps to 395 volts. Apparently we far exceeded 450 because, yeah, it went pop. But yeah, I can see where they were crawling around, and there's arc spots right around these. I don't know if you can see it too well. Let's see these resistors. Trying to make sure they show up. Right in there. There's a couple of I can't remember the value. They're high value in the mega ohm resistors that are part of that feedback circuit. And if you mess with those, your boosted power factor correction voltage can go wild, and that's what happened, I believe. Let's clean this up a little. All right, let's see, what did we... I know we lost a capacitor. What else did we lose? Go into continuity mode, maybe. Did we manage to blow our fuse this time? We did not. Let me null that out. We did not blow our fuse. Did we blow this fusible resistor right there? That's a 0.1 ohm. We did not. Did we blow some of these MOSFETs? I'm going to guess not, because we would have blown the fusible resistor. Checking these MOSFETs. No. Nothing shorted. I wonder if our resistor survived. Those feedback resistors. Let me look right quick, like I can get the values off of those. 7.5 megohms. As best I can remember, it's 7.5 megohms, and there's like another 100K closer to the DAP53. Like this one here should tie to the main filter caps. Let me find the main filter caps. Where's the plus? Right there. Is that connected to here? Yes. So you end up with the 395, 400 volts, whatever, right there, divided through two 7.5 megohm resistors, and it goes on down, and there's another 100K to ground, 95K, 100K, something like that, right here by the chip, by the DAP53. Which I'm curious if the DAP53 survived all that nastiness and explosions. Let me find my common negative on those same capacitors. Right there, red probe on there. I'm in diode mode now. Let's see, I think this is pin. Which one's pin 1? I'm looking at it backwards than I normally would. I don't know why I'm doing that. Should be pin 1 here. Yep. That's ground. I think that's 8. This should be like 1.15. Pretty close. So that's 8. That's 9. Let's say 9. 10, 11, 12, 13, 14, 15, 16. All right, it doesn't look bad. It doesn't look shorted. It can still be bad. I've seen some. I worked on one yesterday that seemed to check fine, but it would not run. But we'll leave it in there for now. And I have a feeling these resistors are probably good. We have to look at that under the microscope, though. Really, you can't check these things in circuit. I've tried. There's just unless you lift them or something. There's an alternative path, a parallel resistance path, and you just won't get a true reading. This is a 7.5 megohm, and you'll get nothing. But I doubt very seriously if they're open, because you think about it. It's 7.5 megohms. It takes a lot to push enough current through a 7.5 megohm resistor to burn it open. And see, now I'm getting negative readings for resistance. When you're getting negative readings for resistance on your meter, that means there's voltage there. It's not much, but there's a little bit of voltage there. And it's pushing current, the opposite way through the meter. The meter is trying to supply the current to go through the resistors and then measure that voltage to determine the resistance. And there is something on the board pushing current the opposite way. So that's why you get those negative numbers. Like if I put my negative probe on ground over here, what kind of voltage do we have over here? Just a little bit, 6.5 volts. Yeah, so that'll give us that negative reading. So anyway, we need a capacitor, that much we know. Let me see if I can find one. I may have to pull one out of a donor. The only donors I have are some that I have laying around that are waiting on DMP014s, that little chip, because they're just not available right now. So they're not repairable, those supplies are. And this one may not be repairable. If that chip is bad, she's not going to be fixable unless I steal one from another board, which I've done already. But let me see if I can find one of these capacitors, though. 450 volt, 150 microfarad. All right, looking through my parts stash, it looks like I happen to have one. Exactly. Yeah, there's the part number I used. I think I bought this for a PS4 supply. But yeah, that does look to be correct. Okay, let me get that in there and see if that helps us any. All right, I want to quickly take a look under the microscope in the area where it looks like the bugs have been crawling around causing problems. And these are those resistors I was talking about. 2 7.5 megohms. You can see a little bit of an arc right in there. Clean that out of there. So yeah. And this is the area of the highest voltage inside this thing. This runs right at 400 volts. So when they get in this area, you can see a little arcing trail right there. Make sure that's in the picture. When they get in this area, they don't last very long. They get vaporized pretty much. And I'm hoping I do have some of these resistors. I think I finally bought some of them because I could tell they were kind of critical, you know, for the operation of the power supply. So I did get some on hand, and they're not cheap because I had to get like I believe they're 1% or better. I can't remember. They're pretty tight tolerance. Because they need to be to regulate that voltage. The capacitor had a little bit of soot on it, but I don't think she's bad. Well, hate seeing those char marks down in there. Don't think they're going to hurt anything, as long as they're not, you know, a solid line of carbon across there. Okay. All right, let's give this thing a try. I'm going to hook it up to my you know, variable AC supply and bring it up slowly. And I have checked continuity between here and here. These resistors are in series. And it looked like that tracer had been a little hot, but she's still there. But it had blown the solder mask off of it. So it looks like a mark on top of that resistor. That's going to scrape off. Okay. Yeah, they cleaned me up pretty good. All right. Let me get set up and we'll see if it works or if it goes boom. All right, I think I've got everything set up. I've got my electronic DC load set up over there. Set on about 6 amps, I think. Yep, she's on. I have a meter across the these bulk filter capacitors that should be running at 395 volts. So we'll check those. See, just kind of curious what that voltage is going to go to. And I have my AC connected to my variable AC supply over here, which I'm going to turn way down, turn on, and start easing up, as you can see over there. And we'll just see what happens here. As I'm still easing it up. Approaching 80 volts AC in. Oh, she's trying to run. There we go. Yeah, somewhere around 90, or I think 90, 100, somewhere it kicked. It started trying to run. All right. That looks nice and normal and safe. 396 volts or so. Wandering around a little bit there with the load. Yeah, that looks good. All right. I'm gonna let this run a little bit, and then probably do a little cleanup on it. Definitely do some cleanup on the chassis, on the plastic housing right there. And then we're ready to test this out there in the chassis. As soon as I clean the chassis up, it's going to need the spa treatment. So let me get to it. Well, the power supply has been repaired. The parts of the power supply cleaned and reassembled. The case has been disassembled and cleaned. It's all come back together now. Will she turn on? Let's find out. Blue lights. And there it goes. All right. All right, so this one was nasty. I don't. It's not the worst I've seen, but it was pretty nasty. But a little cleaning and repairing that supply, that's all she needs. She's ready to go back and play games for somebody. Well, I hope you liked that one. Thought it was somewhat interesting, entertaining, educational, or something. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.